Hi everyone, I hope that you are all doing well. What I decided to do was make a review video of the last several videos that we've been going through. I've compiled 9 multiple choice questions that are mostly old actual AP questions, and they're kind of a mix of the videos that you've most recently watched when you've been home during this snowstorm, and also ones that you viewed before we were off. So if you go on the web page, on the same web page that you found this video, at the very bottom there is a link for a Word document, and that is called Derivative Applications Review, and that has the 9 questions. If you just want to print that out, and then you can kind of follow along, cut them out and put them in your notebook, or don't. It's totally up to you what you want to do with this review. If you want to try the problems on your own first and then go through and check your work against mine, that's totally fine too. I just wanted you to have an opportunity to practice all the different problems that we've been doing. Okay, so here we go. Okay, this first question says a particle moves along the x-axis with its position at time t given by x of t equals t minus a times quantity t minus b, where a and b are constants and a does not equal b. For which of the following values of t is the particle at rest? Okay, so if we're talking about the particle being at rest, hopefully you are thinking that you are looking for the velocity, because rest is talking about a stoppment of movement. And as soon as we're talking about movement, we are talking about velocity. So that means I need to take this function, which is the position function, and find the velocity. Okay, I have 2 different options for that. If you look at my position function, it is the product of 2 binomials, t minus a and t minus b. So, okay, to find the velocity function, I need to take the derivative of the position function. I have 2 options for how to kind of get this started. I can take the derivative just as I see it right now and use my product rule. I could also go ahead and multiply the t minus a times t minus b for the position function, and then once I've multiplied that, then I could go ahead and find the velocity. I'm going to go ahead and do that. I think it might be easier. You can do it either which way. So you'd get t squared, and then you'd get minus bt minus at plus ab. Okay, so now when I take the derivative of that, it would be the velocity function. I'd get 2t. All right, remember b and a are constants, so the derivative of negative bt would just be negative b, and the derivative of negative at would be negative a, and the derivative of a times b would be 0. So there's my velocity function. Now, if I am asking when it's at rest, it is a particle is at rest when the velocity is equal to 0. All right, so I'm going to go ahead and set my velocity function that I found here equal to 0. And I need to solve for t. So I'm going to go ahead and add the b and the a over. So I would have a plus b equals 2t. And then I would divide by 2. So I'd have t is equal to a plus b all over 2. And so if I look at my choices, which one does that match up with? And hopefully you all see that that matches up with choice B. Okay, this next question is actually a pretty popular question on the AP exam, or something like it. The function g has the property g of x is less than 0, g prime of x is greater than 0, and g double prime of x is less than 0 for all real values x. Which of the following could be the graph of g? All right, so it's really important that we're able to break down the information that they give us in order to kind of analyze that and then to be able to make a correct decision. So I'm just going to kind of take apart these 3 pieces of information, these critical pieces of information, and see what they tell us. All right, so if g of x is less than 0, what does that tell me about the graph of g? Because remember, we're looking for information about the graph of g. All right, so if the original graph is less than 0, what does that mean? Well, it means that g is going to be below the x-axis. It means that all of my values, all of my y values, g of x is the y, are less than 0, so are negative. Okay, so that's what that first piece of information. All right, so right away I can immediately cross out, just by understanding that first piece, I can cross out choice B and choice C, because those graphs of g are above the x-axis. All right, the next one says g prime of x is greater than 0. So what does that mean when the derivative is greater than 0? It means that the derivative is positive. If I think about my sign chart, if I have a derivative being positive, what does that mean about the g function? So I'm talking about when I have these. If I have g prime and I have g, if I have, say I have my critical values here and here, if I had a plus sign here, what would I put down at the bottom? I would put an arrow going up. If I have a minus, meaning it's less than 0, I would have an arrow going down. Okay, so we are focusing in on this category right here, and it's telling us that if g prime is greater than 0, that would mean that g is increasing. Oops, if I could spell. Okay, so g is increasing. So I'm looking for a graph that is increasing. All right, so if I look here, I can tell that right away d is not. A starts off as increasing, but then starts decreasing. So technically A should be gone as well. All right, let's just make sure of our last thing that they give us and make sure we are confident that it's choice E. The last thing they tell us is g double prime of x is less than 0. Okay, so now let's think about if we had a sign graph for a g double prime, okay, a sign chart, and we had a critical value here, all right, and we had a plus sign or a minus. If we have a plus sign, what does the second derivative tell us? It communicates about the graph of g, whether it's concave up or concave down. So if the second derivative is less than 0, then we know it's concave down. So that's telling us it's concave down. G is concave down. So if I look at my last choice, is this in fact a graph that is concave down? And I would say yes, it is. So it's increasing, it's concave down, and it's below the x-axis. Choice E is the correct choice. Okay, number 3 says the function f given by f of x equals 2x cubed minus 3x squared minus 12x has a relative minimum at x equals what? Okay, so they're looking for a relative minimum. All right, so I need to have memorized. When I'm asking for a relative minimum, I'm looking at the first derivative. Okay, and it's relative, not absolute. So relative minimum means I'm going to take the first derivative, 6x squared minus 6x minus 12, and I'm going to first look for the critical values. For any kind of minimum or maximum, I need the critical values. So 0 is equal to, I'm going to go ahead and factor out a 6. It'd be x squared minus x minus 2. And so that would factor into x minus 2, x plus 1. So x equals 2 and x equals negative 1 are my critical values. Okay, now, when you're talking about relative min and relative max, that's when we use our sign chart. Okay, and so we have f prime and f. And we're going to put our critical values on our sign chart. And we're going to go ahead and test values to the left and in between and to the right. So if I test negative 2, and remember, I'm testing it into my derivative function. Okay, so if I test that negative 2, I would have a negative times a negative, which would be a positive, which would tell me that f is increasing there. Okay, if I test 0, that's in between negative 1 and 2, it'd be a negative times a positive, so I'd have a negative, which would tell me that it would be decreasing in that interval. If I test a 3, I'd have a positive times a positive, which would obviously be positive, and that means I'm increasing in that interval. Okay, so where is my relative minimum? All right, now remember, these arrows kind of communicate to us. You can tell you're going to go up and then down and then back up. So where's my relative min? Well, that's happening right here when x is 2. So when x is 2, I'm at a relative min. Okay, number 4, let g be the function given by g of x equals x times x minus 2 squared. The graph of g is concave down. Okay, concave down. When we're talking about concavity, we need the second derivative. Okay, so if I look at my g of x function, I am noticing that g of x is in fact x times x minus 2 squared. All right, x minus 2 squared is something, again, kind of like the first one we did. I might, rather than using, I'd have to use the product rule and the chain rule to take the derivative. So I'm just going to go ahead and multiply out x minus 2 squared. So I'd have x times, this would be x squared minus 4x plus 4. And then distribute that x through, I'd have x to the third minus 4x squared plus 4x. Okay, that to me is much easier to take the derivative of. Okay, so that was my choice. So now I'm taking the first derivative, and that would be 3x squared minus 8x plus 4. But remember, we need the second derivative for concavity. So the second derivative here would be 6x minus 8. Okay, so, and I need to find the critical value. So 0 equals 6x minus 8. So it's going to be 8 divided by 6, which is the same as 4/3, of course, for x. Okay, so we can see we're on the right track because choice A and B have a 4/3 in them, so that is encouraging to us. All right, so now I'm going to go ahead and set up my sign chart, but this time it's for the second derivative. Okay, so obviously 4/3 goes on there. And I'm looking for a number less than 4/3 to test and bigger than 4/3. And I'm testing it into my derivative, my second derivative. Okay, so if I test a 0, that would be 0 minus 8 would be negative. So I would have a negative here, which would tell me this would be concave down. All right, and then greater than 4/3 would be a number like 2 or 3. And if I put one of those in, I get a positive, which tells me I'm concave up. So if they're asking where am I concave down, well, I would be able to conclude that I am concave down when x is less than 4/3 because that's where the second derivative is less than 0. So that would be choice B. Okay, number 5 is another pretty popular question on the exam, and it oftentimes trips students up. So let's read through it. Let f be a twice differentiable function. Means you can take the derivative of it twice, and f prime of x is greater than 0, f double prime is less than 0. For all real numbers x such that f of 3 is 10, okay, I'm just going to kind of gather this information, f of 3 is 10, f of 4 is 15. What is a possible value for f of 5? Okay, so we need to analyze what this is telling us in order to answer this question correctly. So once again, what do we say it means when the first derivative is greater than 0? It tells us that f is increasing. So that means that our y values should be increasing for the original function. And if you look here, okay, we were going from 10 to 15 is increasing. So that means that my f of 5, since this is counting in order, 3, 4, 5 for the x's. As x is increasing, my y should be increasing. So that tells me that f of 5 has to be bigger than 15. It can't be equal to 15. It has to be bigger than 15 in order for me to continue to increase. Okay, so if I go look at my choices, I can get rid of the first two right away. Okay, so now is it 18, 20, or 22? Well, that's where the second derivative comes in. The second derivative is less than 0. What does that mean? Well, first of all, I know second derivative talks about concavity, so it means that I'm concave down. All right, if I'm concave down, what does that mean about the slopes of my graph? Remember, concave down means, first of all, you can tell it's increasing, but it's increasing at a decreasing rate. So that means my slopes, this is indicating that my slopes are decreasing. Okay, so take a look here. I have to be decreasing at a decreasing rate. Well, right now, okay, I can tell that my x's are changing just by 1, 3, 4, 5. What are my y's changing by? What is the difference in the y's from f of 3 to f of 4? Well, I see a difference of 5. Okay, if I am decreasing at a decreasing rate, it means that the change between f of 4 and f of 5 has to be less than 5. My slope has to be less than 5 going from f of 4 to f of 5. So if I look at my choices, okay, if it was choice C, 18, if this was an 18, what would the slope be? It would be 3. That is showing a decrease. All right, let's look at the next one. If it was 20, well, then you would have a slope of 5, which would not be smaller than 5. Sorry. Sorry, one of the pointers that you can use is a lightsaber, and I didn't know it was on that, so there's the lightsaber. It's very funny. Okay, I hope you got a comic relief by that. It seriously scared me. I jumped when that happened. Anyways, the last option is 22. And so if f of 5 was 22, then obviously my slope here would have been 7, which would be bigger than 5. And so the best choice is that your for f of 5 would be 18. Okay, if you need to go back through so you can hear and understand that again, please do. This is, like I said, it's a pretty popular question, and it's very theoretical. It's very much testing your understanding of your first and your second derivative and how that affects the original graph. Okay, number 6. For t greater than or equal to 0, the position of a particle along the x-axis is given by x of t equals sine t minus cos t. What is the acceleration of the particle at the point where the velocity is equal to 0, is first equal to 0? Okay, so what we are given to start here is the position function, and we're told the velocity has to equal 0. All right, so it sounds like I need to take my position function, which is x of t equals sine t minus cos t, and find its derivative to get to the velocity function. So velocity is going to be cosine of t. The derivative of negative cos would be, well, the derivative of cosine is negative sine, so it's going to be plus sine t. All right, now it's asking when that's equal to 0. So cosine of t plus sine of t. All right, now, this is not anything where I can factor anything out or do anything like that. What I need to understand is that for this to happen, cosine of t, if I just move one of those over, has to equal negative sine t, if I just subtract sine t to both sides. All right, so cosine of t has to equal negative sine t. So if I think about my unit circle, in order for this to happen, in order to add two things and they be opposites of each other, all right, in order to cancel out to give me 0, I must be talking about one of my pi over 4 angles. Okay, if you think about these angles here, all right, at pi over 4, the points are root 2 over 2, root 2 over 2. So in order to have an angle that is the same but opposite, it must be one of those 4 angles. Now, obviously, it's not in quadrant 1 because if I add those, I don't get 0. Okay, but let's look at quadrant 2, which is 3 pi over 4. Now the coordinates are negative square root 2 over 2, square root 2 over 2. All right, that definitely is more like it. Okay, when I add negative root 2 over 2 and root 2 over 2, those are opposites and they would equal 0. All right, now, do I need to look any further is the question. Well, look, it says find what is the acceleration of the particle at the point where the velocity is first equal to 0. So they only want where it first happens. Well, it first happens when t is equal to 3 pi over 4. At the angle 3 pi over 4, cosine of t is equal to the opposite of sine of t. All right, so that's our time. Now we need to find the acceleration at that time. All right, so next step is to go ahead and find a of t. So I'm going to take the velocity function right here, and I'm going to take its derivative. So the derivative of cos is negative sine t, and then the derivative of sine t is cosine t. All right, and now I need to find the acceleration at the time 3 pi over 4 at that angle. All right, so negative sine of 3 pi over 4 plus the cosine, of 3 pi over 4. All right, so looking at this point right here, all right, we know that the points x comma y, cos comma sine. So I know that my sine of 3 pi over 4 is going to be negative of the sine of 3 pi over 4 is root 2 over 2. Plus the cosine is going to be the x coordinate at that point, so negative root 2 over 2. All right, so what happens there? Well, we have the same denominator, so we keep the denominator. Negative root 2 plus negative root 2 would be negative 2 root 2. The 2's here are going to cancel, the whole number 2's, and so we end up with negative square root of 2 as our answer, which is choice A. All right, good job. Okay, if f prime is equal to x minus 2 times x minus 3 squared times x minus 4 cubed, then which of the following is the relative extrema? Okay, and they give us choices. So, and you notice they give us a relative max, relative min, relative max at x equals 2, 3, and 4. Why is that? Well, because if you look at what we are given, we're given the first derivative. We don't have to solve for it. And remember, the first step is to take your first derivative and to solve and find your critical values. Well, since these are already in factored form, your critical values are really easy to find. You're just t-charting each of these, and so it's just x equals 2, x equals 3, and x equals 4. So now what we need to determine is which of those is a relative min or relative max or neither. Remember, it doesn't have to be either. And how we determine that is we look at our sign chart. So I have f prime and f. I'm going to put 2 and 3 and 4 on my sign chart. Okay, and now I'm testing values. So if I test a 0, that's definitely less than 2. And I'm going to test it into this here. Now keep in mind, I always want to look to see if there's any shortcuts. And if you look at this middle term here, it's something squared. So that's always going to be positive. So really we don't have to test into that. We just know that that's going to be a positive. So when I test a 0 into the first term here, it'd be negative, okay, times a positive. We said the middle is always positive. And then 0 minus 4 would be negative, cubed would be negative. So that negative times a negative is going to be a positive, and we're talking about increasing then. Okay. All right, now test a value between 2 and 3, so that would be like 2.5. And if I tested 2.5, well, 2.5 minus 2 is positive. The middle one is always positive. And then 2.5 minus 4 would be negative, cubed is negative. So this is in fact negative, which would be a decreasing interval. All right, now the next, 3.5. So again, that's positive, positive. 3.5 minus 4 is negative. Cubed is still negative. And so we are still decreasing between 3 and 4. Okay, test in a number bigger than 4, say 5. That would be positive, positive, and positive again. And so that is going to be a positive, which means we're going to start increasing there after 4. Okay, so now look at our choices. What's happening here? All right. If you look here, if you follow the arrows, we went up and then we start coming back down. So this at 2, we would say that is in fact a max. Okay, then I'm decreasing, I continue decreasing, and then I start to increase again. So I would say 4 has a minimum. 3 is neither. It's not a max or a min because I didn't change here. I didn't change from my sign for f prime didn't change. It stayed negative and then it continued on negative. And so here, if you look at your choices, is there a relative max at 2? Yes, there is. So that is true. Is there a relative min at 3? No, that's not true. Is there a relative max at 4? No, that's not true. So the only one that is true is choice A, one only. Okay, the next one's also a pretty popular question. It's kind of wordy, and again, making sure that you understand the application of the derivative, the first derivative, in a real-world problem. It says for t is greater than or equal to 0 hours, h is a differentiable function of t that gives the temperature in degrees Celsius of an Arctic weather station. For which of the following is the best interpretation of h prime of 24? Okay, so it says h, which is your original function, gives the temperature. So then h prime of 24. Well, what does the derivative do? Anytime we take the derivative, it's measuring the rate. Okay, it's the slope, it's the rate. So if we look, and then the 24 would be the t, that would be the hour. So specifically, it's looking for the rate of change of the temperature at the 24th hour. So if you read your choices, the change in temperature during the first day, Nope. The change in temperature during the 24th hour. No, it doesn't. It's not the change in temperature. It's the rate of change. We're not just talking about how much it has changed. It's talking about what is the rate of change. So that's not right. The average rate, no, we're not talking about average at all. So that's not it. The rate at which the temperature is changing. Okay, that sounds much better. The rate at which the temperature is changing during the first day. No, we don't want the whole day. We just want that specific time. The rate at which the temperature is changing at the end of the 24th hour. Okay, that is it. All right, so when you put in that 24, it's what is the rate of change for that hour. Okay, last question we're going to look at. It says a particle is moving along the x-axis and its position is given by, I just squeeze mine in, x of t equals 3t to the 5th minus 5t cubed minus 12 during the interval 0 to 2. Which of the following represents the position of the particle when it's furthest to the left? Okay, so we are talking about a position function, and they're wanting to know when it's furthest to the left. So we're talking about moving, and so movement indicates that we are talking about velocity, and we're going to have to use the velocity function. But then the other key here is furthest to the left. That means absolutely the farthest you can get to the left. Talks about an absolute min because it's to the left. All right, so those hints are going to help us a lot, all right, as I read through this problem. All right, so I'm going to go ahead and find the velocity function using my position function, taking the derivative. So 15t to the 4th minus 15t squared, and then minus 0. All right, now if I'm talking about finding an absolute min, I need to find its critical value. So I'm going to factor out a 15t squared, and I'd be left with t squared minus 1. So I would get t equals 0, and t squared equals 1, so t equals positive and negative 1. Okay, so my critical values are 0, 1, and negative 1. All right, now, when I'm talking about absolute min or absolute max, I am not going to do a sign chart. Instead, I am going to do a closed interval test. And if you notice, they gave me a closed interval of 0 to 2. My heading for this is going to be x, and I am finding when the position is furthest to the left. So I'm looking at the position of the particle at these different times. Oops, this should have been a t, not an x. All right, hopefully you caught me in that. All right, so what times am I looking at? Well, I have to use my 0 and my 2 from my closed interval, and then any of these t values that fall in between 0 and 2. So 0 is obviously accounted for. All right, positive 1 falls in between, but negative 1 does not. So we're going to reject the negative 1 and only use the positive 1. So those are the only three values I need to test, 0, 1, and 2, into the position function. All right, which is, of course, up here. All right, so I'm going to go ahead and plug in the 0. So 3 times 0 minus 5 times 0 minus 12 would just be negative 12. All right, 1. If I plug in a 1, it would be 3 times 1 would be 3 minus 5 times 1 would be 5 minus 12. So let's see here. 3 minus 5 would be negative 2 minus 12 would be negative 14. All right, and the last one I have to plug in is a 2. So I have 3 times 2 to the 5th, which is 32, minus 5, 2 to the 3rd is 8, minus 12. All right, so that's 3 times 32 would be 96, minus 40, minus 12. So that's 56 minus 12 would be 44. All right, so looking at those, I want to know which one is furthest to left. Well, that would be which position is the absolute smallest. So that would be right here. The absolute smallest would be a position of negative 14. All right, and which of the following represents the position of the particle? So it doesn't want the time, it wants the position, and so that would be negative 14 would be your answer. All right, ladies and gentlemen, thanks so much for going through these problems with me. I hope this helps, and I hope it kind of just, as you approach a problem, gives you some different hints as to how to begin those problems. I'm sure you're going to be seeing a lot of problems like this on your next assessment, whenever that might be. All right, have a great day. Thanks so much.